And then the degrees of freedom for t, we get the number 8, we get it from degrees of freedom of the residual in the ANOVA table. So that is what we need to get the first component after the plus minus for the confidence interval. Then if we look into the formula, it says SE. But what is SE? SE is the standard error. Notice that after the T is SE. SE goes for standard error. And it is given in the first table of the output as standard error. So that's the 75.5 that we have in the equation. And then we start the square root. And the square root, notice that it has 1 divided by n we get out of the observations in the first table of regression. And then we have a series of components that repeats all over for each of the x values, x variables. In this case, we have only one x variable, which is the age of the bus. So we're just going to repeat this component only once. Now it says x1g. x1g is the given value of x1, which is part of your question. In our case, x1g is 6. Then it says x bar 1. Remember that we computed the descriptive statistics for x. Well, that's where it comes handy, because x bar 1 is going to be the average of x. And then it also says n, which we already know it's 10 minus 1 times s squared of x1. S squared, remember, is the variance. So the variance of x1 equals 2. And that's how we complete our equation, and you get a confidence interval. So basically we're 97% confidence that the estimated maintenance cost of one bus that is 6 years of age range between $758 and $1,261. The next question is about prediction of the maintenance cost of a bus. So still is only the y hat or the first y equation, the long equation, of 36 months old. So that would be 3 years old. So we need to check if 3 is within the sample range. For that, we go back to the descriptive statistics and notice that 3 is inside the sample range. So pretty much question number 8 is pretty easy and straightforward. Question number 8 is just plugging in the 3 value. Remember to do the modification of the units into the y hat equation, and that's it. That's all we need. The maintenance cost of a bus 36 months old is $615 per year. They gave us a confidence level. We don't need it, because since it is within the sample range, it's going to be more specific than a value that's not within the sample range, as question number 7. And finally, question number 9 says predict with 98% confidence the mean maintenance cost of all buses. Now mean, as soon as you see mean there, that's telling you that we need to use the y bar equation. There's no question about it, and it's not depending on the fact if it is within or not within the sample range. As soon as it says mean, we're going to use the y bar. And notice that it has very similar to the long equation for y, except that it's not having the 1 plus inside the square root. So now you know how to compute these. You just compute y hat for 6, is that 6? Yeah, y hat for 6, 10, 10, and that's going to be part of your equation. And then t of alpha helps, alpha changed to 0.02, times 2, comma, degrees of freedom from the residual, times SE, the standard error, and then complete the rest. Let me just make sure I do it. Verification of this, t inverse of alpha, comma, 8 2.89, 2.90. Okay. It was just 2.90, and then we are 98% confident that the mean maintenance cost of all buses 6 years old range between $840.61 and $1,179.39.